Radar drones transform soil moisture monitoring. Cranfield University leads innovation for flood and drought management. Cranfield University is spearheading a groundbreaking 2-year project aimed at revolutionizing soil moisture monitoring through the fusion of synthetic aperture radar, SAR, and unmanned aerial vehicles, UAVs. Radar drones soil monitoring. Cranfield University. Image credit, Dan Evans, Cranfield University. Synthetic aperture radar utilizes radio waves to generate detailed images of the Earth's surface by bouncing waves off objects, measuring their return time, and integrating the data to create high-resolution maps. The project, under the leadership of Dr. Dan Evans, seeks to evaluate the accuracy and potential applications of this innovative technology in soil moisture monitoring. According to a Cranfield University press release, the initiative aims to enhance flood and drought risk management by acquiring precise soil moisture measurements at the field scale. These measurements will assist farmers in making informed decisions regarding irrigation and preparing for extreme weather events. Moreover, the technology holds promise for assessing the stability of railway embankments. The project also intends to ascertain the effectiveness of radar-based soil moisture measurements across various land use contexts, encompassing grasslands, arable farmlands, and woodlands. In collaboration with Surveyor Limited and other academic partners, Cranfield University secured funding of £30,000 from the Douglas Bomford Trust to support this endeavour. The utilization of radar-equipped drones promises to streamline soil moisture measurements, overcoming the laborious, time-consuming, and costly nature of traditional methods. These drones offer continuous, cost-effective measurements of soil moisture up to 40 centimeters deep, a critical depth for plant growth and yield. While initial findings suggest the efficacy of UAV-based radar in assessing soil moisture, the project will delve into how above-ground vegetation influences the accuracy of these moisture data across diverse land use contexts. Cranfield University, alongside partner institutions such as the University of Sterling and the University of Missouri, will conduct comparisons between UAV-based radar data and conventional ground-based measurements to validate the accuracy of UAV radar relative to existing methodologies. If successful, this technology could be extended to applications such as biomass mapping and yield measurements. Dr. Dan Evans, lecturer in soil formation at Cranfield University, emphasized the project's ambition to push the boundaries of radar technology through the integration of UAVs. Through mounting synthetic aperture radar onto drones, we can conduct comprehensive radar surveys of fields, providing us with detailed measurements of soil moisture. This has significant implications for managing flooding and drought risks. With increasingly warm summers and the threat of extreme weather events, monitoring soil moisture becomes crucial for optimizing irrigation practices and mitigating the impact of flooding. Our goal is to validate the accuracy of UAV radar in comparison to traditional methods, paving the way for scalable and cost-effective soil moisture monitoring solutions. This technology has immense potential not only for agriculture but also for environmental monitoring, biomass mapping, and yield measurement. The project holds promise for transforming soil moisture monitoring practices, offering a potential breakthrough in flood and drought management strategies.